Completing the square. So chapter 7 is about, let me just check just to make sure I'm correct. It's about quadratic functions. Everything that we sort of haven't covered about quadratic functions. The only thing that what we actually have covered about quadratic functions is how to add, subtract, multiply, divide polynomials. And then we have covered how to factor. And that was sort of like Math 61, Math 63 stuff. So we're going to go from here, we're going to sort of add in all the extra stuff. So it's almost like we did the skeleton stuff, and now we're going to add in a little bit of the meat and the bones here. Okay, so completing the square is the first thing on the list here. With quadratic functions, we actually have not only can you factor to solve a quadratic function, we can actually do it by another way called completing the square. So we're going to learn that way. Alright, what in the world is this? It says if you can form a perfect square on one side of an equation, set equal to b is some kind of real number, what we can do is we can take the square root or divide it up into sort of two different pieces here. We can say a is equal to the square root of b, a is equal to the negative square root of b. Alright, a little better way to show this usually in other math textbooks here. As soon as my pen decides to work here. Alright, almost. There it goes, okay. Another way to write it, you can write it as a squared is equal to b, and then from then, what happens is you get a is equal to plus or minus the square root of b. So this little plus or minus takes care of really both these statements, so we don't have to split them off into two different pieces. We can sort of keep it as one single equation all the way through. Cool. So you'll see that quite a bit as well. But let's go for it. Let's do just an example here just to get us thinking about this here process. I think we've seen this before. X squared is equal to 16. We want to solve this. And the only rules that we have so far is just factoring. So if we see an x squared, normally what we do is we set equal to 0. So in this case we would subtract 16 from both sides. We would factor, let's see, difference of two squares, right? 16 is really 4 squared, so therefore it would be x plus 4, x minus 4, or the other way around, x minus 4, x plus 4, either or is fine. Alright, and again, you can probably go directly to answer at this point here. You can split them off into two different pieces. So the x minus 4 is equal to 0, x plus 4 is equal to 0. Alright, and so x is equal to 4, x is equal to negative 4. Notice there's two different answers here. One's a positive, one's a negative. So let's go this new way here. Let's see if we can sort of solve it this little square root property method here. So same exact problem, just done a slightly different way. So I see x squared. X squared is a perfect square on the left-hand side. This is what I'm going to do. I'm going to take a square root. And we know a little something here. If you square something and you take the square root of something, don't you just wind up with that something? Okay, the only thing is notice over here there's two answers here. There's a positive and a negative. So in order to compensate here, what we do is we put a plus or minus here. Okay, technically, what we should do the same thing to both sides, right? So we technically should put a little plus right here and a minus here. We don't. Math people are generally lazy because it's going to cancel anyways, so why put extra work when you don't have to? Cool. But technically, yes, there should be a little plus or minus there too, because we are doing the same thing to both sides. And voila, how about this here? Plus or minus, let's see, 16 is a 4, so don't I get the same exact answers on both sides? Awesome, with a lot less work, wasn't it? I think there's a lot less work here. Okay, so let's see just an example here before we get started. Slightly more complicated. This is example number 1 from the textbook. Notice it's not just x being squared. In this case, it's 2x minus 3. That is the item that's being squared, or the binomial that's being squared. If we take the square root of both sides, notice we're going to get plus or minus square root of 25, which is just 5, is that right? Okay, then here's the weird stuff. We're still going to have to add 3 to both sides. I don't want to put it at the end, because then it becomes plus or minus 5 plus 3. Looks a lot neater if we just say 3 plus or minus 5. Then we divide by 2. So we've got this single equation here, and this one we can do in our heads here. So we go 3 plus 5 is 8, divided by 2 is a 4. Then 3 minus 5 is a negative 2. Negative 2 divided by 2 is a negative 1. And then the solution set are these two numbers. We good there? So it's whatever. It doesn't have to be just x. It could be just this binomial. It could be a trinomial. It could be this big old humongous expression, but just whatever is being squared. Okay, anyways, let's jump to it. All yours here for number 1. I think you guys can solve it based upon the previous example. And of course, everybody sort of took a sneak peek at 7.1, is that right? Prior to coming to class, just to sort of see what we're going to be covering. Alright, let's go with it here. Rewriting the problem here, taking square roots, plus or minus on the right hand side, and then canceling off the square root and the square. Leaves us with 3x plus 2. And how about, that's just going to be a plus or minus 4. In this case, we're going to be subtracting 2 from both sides. And again, we want to write that number in front, so it kind of just looks a little bit better here. Subtracting 2 from both sides gives you 3x is equal to negative 2 plus or minus 4. Divide by 3. And at that point, now we have to do some stuff in our heads here. Or let me just rewrite it here. Negative 2 plus or minus 4 divided by 3. Let me show it to you. So we've got a negative 2 plus 4 divided by 3. Eventually becomes 2/3. On the other side, we've got a negative 2 minus 4 divided by 3. Eventually becomes negative 6 over 3 or negative 2. Are we good there? Alright, jumping to the next one here, maybe letting you guys start first. Maybe give you a little hint here before we start the next one. Is something about complex numbers. And yes, we are going to think about complex numbers here. So something about complex numbers. Alright, let me start it as well. So again, we're going to take the square root on both sides, plus or minus on the right, and that cancels, so 4x minus 3 is good there. Let's see, this is going to be, let's see, 50 is not 50 is 25 times 2, so plus or minus 25 is a perfect square of 5, so 5 goes out. It is a negative, so we're going to put the I value in here. And then we're going to have a square root of the leftovers, which is just a 2. In this case, what should we do next? Add 3 is perfect, yep. We're going to add it to the front of it. So 3 plus or minus 5i root 2. And the next step, of course, divide by 4. And this time we are not going to separate them into two different answers. Because it already shows us the two different answers, right? But everybody knows there's two different answers here, right? There's a 3 plus 5i root 2 over 4. The other answer is 3 minus 5i root 2 over 4. Kind of cool stuff here. So what is the what is the sort of the thrust of chapter 7? 7.1 talks about this extra completing the square or solving square roots by the square root property. And 7.2 is really the culmination. 7.2 says, oh, I can use this property and I can make something called a quadratic formula. And what we want to do is we want to be able to actually build the quadratic formula. We'll see where it's built from. And then we're going to just sort of answer some extra little questions on 7.3 about how to solve equations. What does it mean to have an equation solved? 7.4 deals with the weird ones. How do you solve quadratic equations that are in sort of like weird forms? And then once we pass the solving equations stuff, then 7.5 moves on to graphing parabolas. 7.6 then, how about graphing inequalities inside a parabola? So that's it. So we're going to deal with really 4 sections of this whole concept of solving equations, which is really what algebra is about. All right, next one. Looking at this here, I see an x squared. And maybe I can move stuff over, but then I see this little extra x by the 10, so that's not good. What I need to do is I need to form somehow perfect square here. Hey, real quick here, isn't x squared plus 10x plus 25, isn't that a perfect square of something? Yeah, that should be a perfect square of x plus 5. Alright, and going back to Math 61 real quickly here, how do we know that? Because there's a little relationship here. Because if you take half of 10, would that become a 5? And if you square it, would that become 25? So it's this little relationship of taking half of the middle, squaring it to see if it is total at the end. 20 does not change on that side, but I think you guys can finish it off. So all yours to finish it off. All right. Again, I'm going to try to just look up when you're done here. How about square root of both sides, plus or minus on the right, cancel off on the left, x plus 5 on one side, and let's see, 20. 20 is 4 times 5. So that means 4 is the square root of 2, so 2 gets to go on the outside, so how about plus or minus 2, root 5. Finishing off, what should we do? Perfect. X equal to negative 5, plus or minus 2 root 5. Okay, and again, we talked about it. Just want to give you an extra little reference here. This is the trinomial, because we're going to be dealing with this in just a second here. And this is the perfect square binomial. This is inside your textbook here. Anybody know what page number? .428, yeah? Okay. Page 428. And I just want you to notice this relationship here. If you take half of this, that would be a 3, and if you square it, it becomes the 9. And there's your 3. And notice also the signs here. If this is a negative, that's a negative. Positive, positive. Negative, negative. Positive, positive, as we look at patterns. So then 8, half of 8 is 4. If you square the 4, it becomes a 16, and of course there's your 4. And we already looked at this one here, but a negative 10 divided by 2 is negative 5. Square that, becomes a positive 25, but there's the end of the binomial on this side here. Okay, so again, let's look at an example here. And before we get to problem number 4, because since that one got really complicated really quick here, let's maybe like do a couple problems before we get to problem number 4. But let's look at the example first. So what is this all completing the square stuff? Is that many times if you look at x squared minus 6x plus 5, hey, that's not a perfect square trinomial, right? You got a little 5 there. So here's what we do. We're going to form this perfect square trinomial. So we think about it. If you take half of negative 6, you get negative 3, is that right? If you square that, it becomes 9. So we should have a 9 here instead of a 5. So how do we do that? Let's go for it. Let's subtract 5 from both sides and give you this. And usually what happens is you leave this little space. And so if we take negative 6 divided by 2 is negative 3, you square the negative 3, and it becomes a 9. You add 9 to one side of the equation, and of course you have to add the same exact thing to the other. Good there? Once we've simplified that, hey, doesn't that look like more familiar stuff right here? Take the square root of both sides, add 3, and then take a look at your 2 different answers. Are we good there? So this whole concept is we are the ones forming this trinomial. We're going to form it right here so then we can make a binomial in its perfect square form. Cool. So let's jump to some extra practice here. First here. All right, first things first, let's move this little negative 12, let's move it over here because this is not a perfect trinomial. Let's move the 12 over. We're going to be adding 12, and then let's leave a little bit of room here. So exactly we want this little room of what we're going to add in to form that trinomial. So let's go for it here. So let's see, 4. 4 divided by 2 is going to be a 2. And if we square the 2, there's some work for it here. Everybody good there? And if you square the 2, it becomes, we're going to be adding 4. Question? Cool. Okay, I'll answer that in just a second here. Okay, whatever we do to one side, we're going to do to the other. All right, and the question came up is, why do we divide by 2? Why is it 4 then divided by 2 then that? So let's jump to this. Back to here. So first of all, we should notice a pattern here. Here's a pattern that you want to notice. Is that if you take this negative 6, if you do divide it by 2, it gets you negative 3. And if you square the negative 3, that's what gives you the 9. So this is just trinomials on one side, perfect binomials on the other. We're good? And we start just sort of noticing a pattern here. That 8 is really twice that 4. That negative 10 is really twice the negative 5. So
do you take half and then square?
You got it. So then relationship from here to here is that you take half of 12, which is 6. You square it, becomes your 36. Okay, that's one way to explain it. Another way to explain it is this whole concept right here. Let me just kind of do plus 7 as an example. Notice what happens here. If you FOIL things out, notice you get a x squared. Notice you get a 7x. On the inside terms, you get another 7x. There's your 49. Is that 7 squared? But here's what I see. I see really a double of the 7x. Does that make sense there? So the x we know is coming from here. We know that for sure. But then the middle's double for perfect squares. So in order for us to not see a 14 here but still see a 7, we take the 14 divided by that, gives you the 7, and if you square it, gives you that 49. Cool? So it's kind of two different ways here. The pre-algebra pattern way and then the algebra formula way. Okay, so I think we're up here, right? Let's see. What we have formed is we formed a perfect square binomial of x plus 2. Everybody agreed there? Took half of 4, gave us the 2, squared it to give us the end number. This guy, 12 plus 4 is 16. And I think from here you can finish it off, if you have not done so already. Alright, square root of both sides, plus or minus, cancel off the square root and the square. How about plus or minus 4? And how about subtract 2 from both sides? And if you can simplify, then please simplify. If you can't, then just kind of leave it here. In this case, I can simplify that. It's going to give me two different numbers here. Negative 2 plus 4. How about a 2? Negative 2 minus 4. How about a negative 6 at the end? So these two are what's going to give me this right here. Okay, now the only question is, could I have done this by factoring? Ooh, tough question here. Two numbers, multiply to negative 12, add to 4. Yeah, that's going to be 6 and negative 2. Is that right, as factors? And so notice 2 and negative 6 are solutions. So yes, I could have done this by factoring. No, that's no problem. I would have got x is equal to 2, comma, negative 6. The only thing the square root method or completing the square method does is allows us to have these complex answers. Allows us to have like the square root of 2 still left over in there, which factoring does not. So really this method is more of a more general form. You get more answers that you could possibly get with factoring. Like on the next one. An extra practice problem here. Question I have here is real quick here. Can you factor this one? Can you get two numbers multiply to 22 but add to 10? I'll sing Jeopardy again. Dun, 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 dun. Dun, 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 dun. Da, 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 da. No, no way to do it, right? 22 and 10. 11 and 2, but they both add up to 14. That's not going to happen. So then you probably should expect some kind of square root in there somewhere left over. All right, I'll let you guys try here. So first things first, what should we do? Subtract that 22 out of there. Leave a little space. So how about a minus 22 on the other side now? Cool. Heard that as well. Take the 10, divide by that by 2. It gives you a 5, and if you square it, it gets you 25 here. So let's add 25. Hey, I think I've seen that one before. If you had 25 on one side, you better add it to the other. Okay, so how about the binomial that's being squared is a plus 5. And how about a 3 on the other side? Good there? So far, so good? And I think you guys can finish it off from here. So all yours. Alright, so take a square root of both sides, plus or minus there, cancel that off. A plus 5 is equal to the square plus or minus square root of 3. Subtracting 5 from both sides, hopefully this is what you guys got. A is equal to negative 5 plus or minus root 3. And of course we're going to do the show of hands. How many got that one before I got it? Okay. About 60% of the class, okay. Alright, where number 4 comes in is the fact that we're going to get some fractions here. So finally example number 4. Can we solve this guy? Alright, so let's see. I'm going to add 4 to both sides, of course. Leave a little space here. So how about x squared plus 3x, space, and then equal to 4. Oh, bummer. 2 does not divide into 3 evenly. So here we go with fractions here. And again, if you can go ahead of me, that's fine. Just have to deal with fractions here. 3 divided by 2 cannot do that, so it stays as 3 over 2. It's just the way we're going to go with it. If we square it, we're going to be adding, anybody know? 9 over 4 is good. Yep, 9 over 4th is what we're adding to one side. Therefore, we're going to be adding 9 over 4 to the other. All right. Whew. And then what's the binomial that's being squared? I know it's x. What do you guys say? Plus or minus sign? What do you guys say? Plus sign. And then what's that number? Yeah, I think I'm going to keep it as a fraction here, 3 over 2, and you'll see why in just a bit. equal to, and then I've got to do this work over here. I've got to simplify this with common denominators here. So maybe off to the side here. 4 plus 9/4. Maybe I could just do like this here. Common denominator would be 4. Pretty good there. Kind of like there's a little 1 right here. So tell me if you guys agree that's going to be a 16 on top of the first fraction. Because there's like a 4 over 1 right here. That becomes 16 over 4. And because if we can always make this into a little 1 right here. So multiply by 4 gives you 16. And this stays the same, so how about a 9 over here? And so how about 25 over 4? Alright, take a square root of both sides, plus or minus. How about that? X plus 3/2 is equal to plus or minus, and then let's see, 25 over 4, isn't that the same thing as 5/2? Okay, and that's what usually is going to happen. You're going to have the same exact denominator on both sides, especially with fractions here. So yeah, we're going to work a little bit more here. Subtract 3/2 from this side. I'm running out of room here, so I'm going to write it as negative 3/2 plus or minus 5/2. And can we simplify that down? Perfect, yep. The question is, does the square root sign go away once you reduce this? Yep, because you're taking the square root of 25, and you took the square root of 4. So it disappeared. The plus or minus still had to stay there.
Would it be right if we left it at the square root 25 over 4? That would be correct if we stop there.
Correct, yeah. If you can reduce a square root, you got to reduce the square root. Yeah, you got to put it in simplest form.
It's already like reduced, so just leave it there.
Let's get to the next one, and then if you guys have questions after that, I think that'll be good after the next problem here. All right, how about, let's see, I got a plus and a minus here. So first things first, negative 3 plus 5 is 2. 2 divided by 2 is a 1. Negative 3 minus 5 is a negative 8. Negative 8 divided by 2 is a negative 4, and I got my answer.
Can't you just factor that?
Ah, cool. The question I was going to ask here. Hold on. We did this work. We did this. We did this, this. Real quick here. Can I factor this? Two numbers multiply negative 4, add to a positive 3. 4, negative 1. Those are the factors. Therefore, 1, negative 4 are my solutions. So hold on. So sometimes factoring is the faster process. Sometimes this little thing is the faster process. So the rule of thumb is, as we get to 7.2, the rule of thumb is you look at this and real quickly say in your head, can I factor this? And if I can, I'm going to factor it. If I quickly look at it and say, can't factor it, then I'm going to go into this process. So put good observation there. Okay, next one, which I think will clarify a few things here. There it is. Again, this is number 5, probably the most complicated problem you'll see of these type, because it's the last problem. So we got a couple of issues here. The first and foremost, the problem is, see that little 5 in front of x squared? Can't have it. Sorry. When we do this completing the square process, I just need an x squared by itself and nothing else in front. So we have to deal with that. But first, let's move the 2 over. So let's subtract 2, move it over. Let me rewrite the problem here because I want to go in order here so you guys can see the development here. So subtract 2, leave some space. So 5x squared minus 3x. Space. Not that much space left, but at least something. So that's the first step. Move over that constant to the other side. Second step is to get rid of that 5. So since we have an equation, since we have equal signs, I can divide each of those terms by 5. And I'll be left with x squared. Let's see, minus 3/5 x. Leave a lot of space there. Negative 2/5. And again, it's supposed to be the most complicated here. That's the whole point of it. Whew, okay. So here's the question. The question is, what am I adding here to form a perfect square trinomial? Gotta put your thinking caps on here. Let you guys ponder it for a little bit. So let's see how we do this here. Let's see, it's going to be negative 3/5 divided by 2, is that right? We're going to take half of that. But that's not what we do with fractions. What we do with fractions here is we don't divide fractions, we multiply fractions. So how about negative 3/5 multiplied by, anybody? 1/2. So how about we get ourselves a negative 3/10, is that right? Okay, negative 3/10, and then we're going to square this guy. So that guy's going to go over here. So with fractions, we divide by 1/2 as opposed to, oh sorry, we multiply by 1/2 as opposed to divide by 2. Whew, how about 9/100ths? That has formed that perfect square trinomial. Alright, whatever we do to one side, we better do to the other. So how about 9/100ths to the other side? Now the two people to look ahead into 7.1. It's a lot better now, maybe. Okay, let's figure this out. This is going to be, let's figure this out so we can have a simplified answer here. Common denominator here would be? I go with 100, is that right? So I gotta multiply this guy by 20, multiply this guy by 20, how about a negative 40? With a 9, and how about a negative 31 maybe? Yeah. Okay, got that one. So now let's put it all together. Let's see if we can. So on the bottom here, the perfect binomial that was squared would be x minus 3/10. Is that right? There's my binomial that was supposed to be squared to form this perfect trinomial. On the right hand side, I got myself my negative 31 over a 100. Again, this is the complicated one. If you're still keeping up with everything here, then we're still good. Okay, take square root of both sides, plus or minus, of course. And we get ourselves x minus 3/10 equal to, okay, let's do this slowly here. Plus or minus, first of all, that's there. I have a negative inside the square root. 31 is not a perfect square, but 100 is a perfect square. We're good? So how about an I gets to go out because of the negative. 31 is not a perfect square, so it stays in as a 31. But 100 now becomes 10. Everybody good there? Those three different parts right there. Alright, with that, I think we're almost done. Let's add 3/10 to both sides, putting that number first. So how about a 3 on top, plus or minus I root 31 divided by 10, and that would be our final answer. It is a complex answer. As we talked about yesterday, some kind of application in electrical engineering maybe, or something like that at this point with that one. Okay, good there. And let's, again, if you got that and everything makes sense in your mind, you're doing good. Because homework should not be that bad then. All right, let's jump to an application, a geometry application. And we're going to get to just two little triangles. This is really set up for Math 15 or pre-calculus. Those are going on to that. But you got two different special triangles here. One is called a 30, 60, 90 triangle. Remember, this little box always represents 90. And the other special triangle is a 45, 45, 90 triangle. And the reason for it is because we can actually figure out the exact length of each of these sides really easy. If this was 48 degrees and this was 52 degrees, then forget it. It's not going to work. But it's because this relationship between this guy's the double, this angle's the double of the smallest angle, this is the triple of the smallest angle. This one is, they're both the same. So that's why. But so let's take a look at it here. Again, just to kind of set up more for pre-calc here. If the shortest side in a 30, 60, 90 triangle is 2 inches long, can we somehow figure out the other two sides of that triangle? Is there a certain way to figure that out? How can we figure it out? Okay, the trick really, it comes into this right here. Instead of making a 30, 60, 90 triangle, what we're going to do is we're going to make ourselves something called the equilateral triangle. Anybody remember what equilateral means? Yeah, all the sides are the same dimension. All right, and then do you know anybody what are the angle measurements? Because the angle measurements then have to be exactly the same. Those are all the same, and they are all 60 degrees. So this is 60 right here, this is 60 right here, and this is 60 down here. So again, I'm going back to this geometry here. What I'm going to do, I'm going to drop something called an altitude. Going straight down. Make yourself a right triangle here. So if this was an equilateral triangle, we know a little something from geometry, and again, this little formula comes from geometry, is that on an equilateral triangle, when I drop my altitude, these two sides will be exactly the same, and my angle will be cut in half. And again, that's a little theorem from geometry that we're not going to go into right now. But if I do that, that's still 60, is that right? This guy is a 30, and there's my 90. Hey, look at that. There's my 30, 60, 90 triangle formed. So let's see what we got here. So if the shortest side of a 30, 60, 90 triangle is 2, so that means that's not the shortest side. This one looks like the shortest side right here. So this means this guy had to be a 2. Okay, if that guy is a 2, we know automatically what this guy is right here. What is this? How long is this?
4.
Yeah, 4. Remember, because this, the altitude cut it in half, so that means this also has to be 2. Therefore, each of the sides are 4. So let's go with 4. And the one that we don't know at all, we're just going to label as x. But we do have something called the Pythagorean theorem. Is that right? Something about the square, the sum of the legs squared equal the hypotenuse squared, right? So let's go with a squared plus b squared equals c squared. That's normally how it's written. But really the a and the b are just legs here. So I'm going to use the 2 for the a, x for the b, and 4 for the hypotenuse. So how about 2 being squared, x being squared for b, and c is a 4 being squared. Can you solve for x? That's your job. Can you solve for x? Alright, in this case, how about a 4? How about an x squared? And how about a 16? Hey, in this one, you can't really do this by factoring. This is not possible to finish off by factoring here. As we subtract 4 from both sides, it gets you hopefully a 12. So this is kind of cool. We get some answers that we would never be able to factor down. Alright, how about square root both sides? And something we should know. Real quick here, raise your hand if you put plus or minus. Got 2 of you guys. Okay. Why would I not put plus or minus here? Can't have a negative value because this is a length, is that right? So x could not be so no putting plus or minus, just cancel off the x and you get ourselves a square root of 12, but let's reduce this down. Square root of 12, isn't that really 4 times 3? So 2 on the outside, 3 on the inside, so 2 root 3. Voila, got it. So x is 2 root 3. And we're good there. Alright, at this point then we're going to skip this guy. That's kind of fun, but not right now. So we'll stop there for 7.1.